Over 8 billion tons of plastic refuse are slowly turning our oceans into vast floating landfills. The waves no longer taste like salt, they carry the weight of human neglect. While this grim reality has forced many nations to look away, the United States refuses to give in. Here, visionary engineers are determined not to watch the oceans wither silently. They've created an ingenious collection system that lets ocean debris drift naturally into capture zones, guided solely by the power of ocean currents. But what allows this colossal system to operate so seamlessly in the unpredictable expanse of the open sea? Every year, more than 20 million tons of trash pour into our oceans, nearly 80% of it plastic, a material so stubborn it can survive underwater for centuries. These fragments gather into massive floating garbage patches, quietly infiltrating the marine food chain and threatening over 700 species of ocean life, eventually touching human lives as well. Environmental groups highlight that, if properly collected and recycled, a large portion of this waste could be reborn as valuable materials, from repurposed plastics and engineered fibers for textiles to reclaimed metals. This recycling not only conserves thousands of kilowatt-hours of energy and prevents millions of tons of CO2 emissions, but it also nurtures a circular ocean economy, turning discarded waste into resources with renewed purpose. The journey to reclaim ocean waste begins with retrieval. Collecting such enormous amounts of debris in the harsh, unpredictable conditions of the open sea requires highly specialized technology. In major hotspots like the North Pacific Gyre or the Gulf of Thailand, dedicated cleanup vessels act as the workhorses of this mission. Each ship is equipped with 2 hydraulic arms that extend outward, sweeping the surface in wide, fan-shaped arcs to gather drifting refuse. From plastic bottles and discarded bags to abandoned fishing nets, the captured debris is guided through floating channels connected to the vessel and transported onto stainless steel conveyors on deck. From there, the material flows into massive holding compartments. A single operation can last 8 to 10 hours, collecting anywhere from 5 to 10 tons of mixed marine waste in one go. Not all trash reaches the open ocean. A significant portion becomes trapped in rivers, reservoirs, and canals, accumulating in thick layers that block water flow. In these settings, compact mechanical tools are deployed, most often clamshell excavators mounted on dump trucks. Each steel bucket, weighing nearly 1,000 pounds, plunges below the surface to scoop up mixed debris, bottles, plastic bags, branches, and even old tires. Each lift can haul between 500 and 1,000 pounds of waste, and with hydraulic assistance, a single crew can clear hundreds of feet of river in just a few hours, almost 10 times faster than manual labor. Yet in many coastal communities, cleanup still relies on local fishermen and volunteers, armed with small nets and hooks, braving the sun's heat. While each person may collect only a few £100 per day, their efforts form the critical first link in the ocean's recycling chain. Once the retrieval phase is complete, the collected debris is transported back to shore by specialized trash skimmer vessels, boats designed specifically to harvest floating waste. A typical skimmer, around 25 to 30 feet long, can gather up to 5 tons of material during an 8-hour operation. When the vessel's storage is full, a hydraulic conveyor at the bow lifts and empties the entire load into the receiving area on land. This marks the beginning of the preliminary sorting stage. The freshly offloaded mixture contains a wide array of items: plastics, metals, wood, seaweed, and organic sludge. Workers perform a quick inspection to remove oversized or hazardous objects such as steel nets, oil drums, and tires. The remaining material is then shoveled onto a feed conveyor, which moves it into the screening system. Inside the sorting line, a tumbling drum separates the waste by particle size. Sand, silt, shells, and tiny fragments fall through perforations, while bottles, packaging, and larger debris remain inside. This residual stream, primarily plastics and nylon, is then transferred to a manual sorting belt, where workers meticulously separate each type in preparation for the next stage of recycling. Once sorting is complete, materials like metal, glass, and wood are directed to their respective processing lines. Plastic, the planet's most persistent yet challenging material, is set aside to begin its transformation. From here, humanity's ingenuity turns drifting marine debris into valuable resources, fueling a more sustainable future. Once the recyclable portion, primarily plastics, nylon, and metal cans, is separated, it moves into the washing stage, a crucial step before any recycling can begin. Ocean debris often spends months submerged, coated with salt, algae, oils, and microbial buildup, making thorough cleaning essential. In the processing zone, the material enters a mechanical wash tank, where rotating shafts with paddles create turbulent currents that scrub away surface grime and rinse off impurities. The WA solution is specially formulated with gentle cleaning agents and a chloride-neutralizing compound to remove salt and all residues. Some facilities enhance this process using hot water between 160 and 180 degrees Fahrenheit, improving sterilization and cleaning efficiency. This washing cycle typically lasts 15 to 30 minutes, depending on the level of contamination. Afterward, the debris moves into a spinning drum washer, where high-pressure water jets dislodge stubborn sand, algae, and other residues. The plastics are then sorted by density in a floating tank. PET sinks to the bottom, while HDPE and PP remain buoyant, ensuring accurate separation for recycling. Next, the clean material is sent to a centrifugal dryer to remove excess moisture, followed by hot air drying around 170 degrees Fahrenheit. In larger plants, ozone-based deodorizing systems treat vapor emissions, neutralizing odors and bacteria for a hygienic workflow. Before moving into advanced recycling, the plastics undergo pre-sorting by type and size. While 7 major plastic types exist worldwide, PET and HDPE are the most efficiently recyclable, so these are prioritized for processing into new, valuable materials. The system focuses on isolating these high-priority plastics while removing incompatible materials. The mixed plastic feed is then guided into a large rotating steel drum. As the drum spins, tiny perforations allow dust, sand, and fine particles to fall through, while larger items like bottles continue along the line. This initial classification helps prevent clogs in the machinery further down the process. Next, the stream moves along a manual sorting line, where workers remove unwanted items such as metal cans, nylon, and cardboard. At the same time, an automated cap and label remover uses vortex air pressure to strip off different plastic components, while magnetic detectors continuously identify and eject any leftover metal pieces or staples. After this mechanical purification, what remains is primarily clean, uniform PET bottles, now ready for the grinding phase. The bottles are fed into a high-speed granulator, where hundreds of alloy blades spin at thousands of revolutions per minute, slicing the plastic into small flakes. In just 1 hour, a single machine can process between 2,000 and 3,000 pounds of material, transforming what was once a mountain of bottles into a steady flow of uniform plastic flakes within minutes. The resulting plastic flakes, just a few inches in size, are small enough to flow smoothly through the next thermal processing systems without causing blockages. This grinding step not only reduces the bulk of the material but also improves energy efficiency in later stages. Once broken down into uniform fragments, the plastic melts faster in the extrusion unit, cutting electricity consumption by up to 40% compared to melting solid chunks. Granulation also provides the first level of size control, ensuring a consistent feedstock for the precision sorting phase that follows. At a microscopic scale, high-speed optical systems take over. Sensors examine each flake in mere milliseconds, analyzing color, clarity, and surface characteristics. When a fragment is identified, whether a transparent PET piece, a green PET shard, a white HDPE flake, or an unrelated item like wood or glass, a pinpoint jet of compressed air ejects it from the mainstream. Each system can process over 1,000 particles per second, achieving accuracy levels above 95%. Every tiny air pulse targets just one fragment, weighing less than 1,000th of an ounce, without disturbing surrounding material. The result is a continuous flow of clean, uniform plastic flakes, neatly sorted into separate categories, forming the perfect foundation for the pelletizing stage that follows. The approved plastic flakes are fed into a large-scale extrusion unit, where they are heated to around 120 degrees Fahrenheit. At this temperature, the plastic softens and flows along a massive rotating screw. As pressure builds, the molten material is pushed through an ultrafine metal screen, capturing any remaining contaminants. The purified plastic melt then enters an underwater pelletizing system, where it is instantly cut into millions of tiny granules, known as pellets. A closed-loop cooling circuit immediately solidifies these pellets, giving them a uniform size and smooth surface. These industrial-grade pellets become the raw material for producing packaging, synthetic fibers, or even brand-new bottles, completing the transformation from discarded ocean waste into valuable resources. From these recycled PET pellets, the factory moves into the preform molding stage, the process where a partially formed shape is created before becoming a full bottle. The plastic is first checked for consistency and then heated to approximately 480 degrees Fahrenheit in an injection molding unit. In this softened state, it is injected into a steel mold, forming a thick-walled tube with a threaded opening designed to fit a bottle cap. Each preform is engineered to withstand high temperatures and internal pressure, ensuring stability during handling and the later reheating phase required for blow molding. Its compact shape also makes storage and transport highly efficient. Many manufacturers specialize in producing these preforms and ship them to bottling plants near consumer markets, where they will be reheated and expanded into their final bottle form. In the next step, the preforms are gently heated until they reach a rubber-like pliable state, then moved into a stretch blow molding machine. High-pressure compressed air is injected through the neck of the preform, forcing the softened plastic to expand and press firmly against the interior surface of a metal mold shaped like the final bottle. A preform just 4 to 5 inches tall can stretch to nearly 4 or 5 times its original size. Once the blow molding step is complete, each automated line can produce thousands of bottles in mere seconds, with virtually no defects. Advanced laser-based inspection systems continuously monitor wall thickness, symmetry, and transparency, ensuring each bottle meets strict quality standards. Beyond standard bottle shapes, the machinery can adjust volume, contour details, and label placement to match precise brand specifications. After leaving the mold, the newly formed PET bottle is still extremely hot and vulnerable to distortion. To stabilize it, the production line immediately moves the bottle into a rapid cooling chamber using either chilled air or circulating water. This quick cooling, lasting only a few seconds, locks the bottle's shape in place. In some modern facilities, the heat released by the bottles is captured and reused to warm the cooling water, reducing overall energy consumption. Once fully solidified, each bottle achieves the mechanical strength needed to withstand internal pressure during filling and transport. The cooling process is carefully calibrated to maximize production speed while maintaining perfect clarity, rigidity, and structural integrity. Before leaving the production facility, every plastic bottle undergoes thorough quality inspections. Optical sensors, high-resolution cameras, and pressure testing systems detect even the smallest imperfections, micro cracks, trapped air bubbles, or inconsistencies in size and shape. Selected bottles are further tested for mechanical durability, including tensile strength, compression, and impact resistance. For bottles intended for food and beverages, additional chemical screening ensures they are completely free from harmful residues. Only after passing all these rigorous checks are the bottles grouped, stacked onto pallets, and shrink-wrapped for protection. Automated palletizing robots then arrange thousands of bottles with inch-level precision, assigning each batch a unique traceability code. From the central distribution hub, the finished products are shipped to bottling plants, supermarkets, and retail stores, completing the incredible transformation from discarded ocean waste to a usable consumer product. Each newly produced bottle represents more than just packaging. It embodies a circular, sustainable system, where discarded materials are reborn as valuable resources. So, you've just followed the full journey of ocean-bound plastic, from collection and cleaning to recycling, processing, and finally transforming into new bottles ready for use. From drifting debris in the sea to industrial-grade resources powering modern manufacturing, the process is far more remarkable than it first appears. All the information shared in this video comes from multiple reputable sources. If you notice anything that could use clarification or correction, leave a comment below. And if you believe recycling can shape a more sustainable future, don't forget to like, share your thoughts, and subscribe to discover more stories of innovation, renewal, and transformation.